Since the law of conservation of mass states that no atoms can be created or destroyed in a chemical reaction, so the number of atoms that are present in the reacted side has to balance the number of atoms that are present in the product side. Thus, there is a need for us to balance a chemical equation for any chemical reaction. In balancing a chemical equation, for example, the equation representing the reaction in between methane and oxygen producing carbon dioxide and water vapor. The first step in balancing is to write the formulas of the substances in the chemical equation correctly. So for example, this is the formula for methane, oxygen, carbon dioxide, and H2O in the form of gas. An arrow in a chemical equation represents or separates the reactant from the product, while a plus sign, on the other hand, is the one that tells us or that separates multiple products and reactants in a chemical equation. After writing the correct chemical equation representing the reaction, we count the atoms of these elements or of the elements on each side of the equation. Since the equation or the chemical equation is always divided into two parts, which is the reactant and the product side, we count the number of atoms in the reactant side and then we count the number of atoms on the product side. For example, we have the atoms of carbon, hydrogen, and oxygen involved in this chemical equation. For the reactant side, we have one atom of carbon, we also have 4 atoms of hydrogen, and we also have 2 atoms of oxygen. We compare the number of atoms in the reactant side to the number of atoms in the product side. For the product side, we have 1 carbon atom, 2 hydrogen atoms, and we have 2 atoms of oxygen in the carbon dioxide compound, and we also have 1 atom of oxygen in the water compound. Since the equation is not yet balanced, we adjust the coefficients to make the number of atoms equal on both sides. Coefficients, as discussed earlier, are inserted before every symbol or formula to tell the number of molecules. For example, in this equation once again, we have, for example, the coefficient for the number of carbon, hydrogen, and oxygen atoms. For the case of carbon, since both carbon atoms on the product and the reactant side are equal, we move into hydrogen. For the reactant side, hydrogen has 4 atoms. On the other hand, on the product side, we only have 2 atoms. So to make the number of atoms of hydrogen equal on both sides, we add the coefficient 2 or before the formula for water. By adding the coefficient 2 before the formula for water, we already have 2 times 2, and that gives us 4. So 4 is already the number of atoms on both sides. By adding 2 as the coefficient of water, this does not only affect the number of atoms of hydrogen, but also the number of atoms of oxygen. So if the subscript of oxygen is 1, this gives us 2 times 1, and that is equal to 2. And 2 times 2 is equal to 4. Now, we go back to the reactant side. Since the number of oxygen atoms is only 2 for the case of oxygen, to balance the chemical equation, we add the coefficient 2 once again. And by adding the coefficient 2, this gives us 2 times 2, and that is equal to 4. Lastly, if exact coefficients are already added, we check the number of atoms, or we check if the number of atoms are the same on both sides. So for the case of carbon, we have carbon on the reactant side has only 1, carbon here also 1. Balance. We check for the case of hydrogen. Hydrogen on the reactant side has 4, and on the product side, that gives you 2 times 2, that is 4. So we also have a balanced number of atoms for hydrogen. For the case of oxygen, we have 2 as a coefficient and 2 as a subscript, that gives you 4. And on the product side, we have oxygen here, which is already 2, which is already 2, and we also have oxygen atom on this side, also 2. So 2 plus 2, that gives you 4, and by having or by adding coefficients earlier, we come up with a balanced chemical equation satisfying the law of conservation of mass in chemical reactions.